Thanks. So I'm here to try and give you a little bit of an overview of what happens sort of in comparison to what you saw in Japan. The bad news is we don't have quite as structured a strategy as they have in Japan. But so one of the things we've been doing over the last few years is to build up a national robotics strategy in the US. And I'll talk a little bit about where those opportunities are and where we see some of this going. So one of the things that's happening in the world, if you get the question, and I got it a few years ago, said you have 30 seconds to convince me that robotics is important. And I said, okay, will help us bring better manufacturing to the US. It will help us improve quality of care for an aging population, and it will secure our first responders. I said, okay, you still have 8 seconds. So it was sort of interesting to try and go in and look at this. And one of the things we're seeing is that we're seeing a world where we're gradually getting to much higher degree of customized products. So we all want to have a product that's our own, whether it's the next generation iPhone or it's the next generation car or it's electronics, it's all highly customized. At the same time, everybody is predicting that autonomous vehicles is going to be the next big thing, and it will sort of get access, whether it's UAVs or self-driving cars. And finally, society is getting older, whether we like it or not. And that sort of plays into how can we actually do this with a shrinking workforce, making sure that people live longer, and make sure that they actually have a reasonable quality of life. So this is a perfectly good Audi A4. It's available in 4 million different configurations. We are all very difficult customers. We all want different audio systems. We all want different seats. We all want sort of anything, so it's my car. That implies that the average automotive factory manufactures the same car every 2.5 weeks. So that poses a huge challenge for us to figure out how can we do automation in the face of these wildly varying products and still make sure that we can deliver it. Of course, today, 1/3 of all cars are made in China. So the big challenge is what can we make sure some of this actually stays in the US. We're seeing autonomous systems, whether it's on the ground or in the air, getting a big renaissance. I'll come back and talk about this a little bit more. And at the same time, the prototypical customer today is sort of the baby boomers. This is the people that have the money. These are the people that will get retired. They want to know, how do I get a reasonable quality of life as I retire? How can I remain in my home as long as possible, in my social circle? How can I have access? So it would be standard functions like, how do I get out of bed? How do I take a shower, get dressed, prepare a meal, participate in social activities? And if I get a mild cognitive impairment, how can I guarantee that I can still function without having to rely on institutionalized care? So this is a big challenge to figure out how do we do this, and how do we do this really well, and at the same time doing it at a reasonable cost. So a number of people have participated with me in writing the National Robotics Roadmap that we started doing 2009. We did an update 2013. And just to tell you how good I am at predicting, the last roadmap was published on November 7th. Some of you might not recognize November 7th, but I'm sure you all recognize November 8th, where we have the presidential election. And November 7th, I had to publish this document, and I had 2 different introductions. I had one for the female candidate, and I had one for the male candidate. And 24 hours before the election, I said, I know where this is going. So I put in the introductions for the female candidate and realized 24 hours later that I was probably wrong. So that tells you how good I am at doing forecasting. But nonetheless, this is a document that we're still using with a number of government agencies to drive forward. And even in the current budget proposal, the robotics programs have not seen a budget cut like a number of the other R&D programs. So it's at least being level. And it does involve NSF, DARPA, a number of the different programs that's talking about where is this going. The roadmap points to where do we think we are 5, 10, 15 years down the road. What are the driving business cases? The good news is, when you've done this for a while, you can actually be benchmarked. Given that we did this 2009 and we predicted where are we 5 years from now, that deadline has passed. And we were actually, the group, it's about 200 people that write the roadmap, pretty good at predicting where robotics would be. The one thing we missed in the 2009 was RGBD centers. So Intel RealSense, Kinect sensors, and those. The same thing from 2013 to 2016, we thought UAVs would actually take up faster than they did. And the main obstacle today is a legal framework to make sure that we can actually fly them in public spaces. But if we dive in a little bit deeper, we're seeing that we can do transformation of manufacturing. So we're getting to a place where we have a deeper penetration into not only sort of traditional manufacturing, but also into assembly. How can we do this in such a way that we can actually start to do a much higher part? So, many people will think about the standard automotive factory as being lights out. The reality is that in an automotive factory that is highly automated today, there's one robot for every 10 people. So there's still a long way to go, and we want to figure out how can we actually go in and have a much higher degree of automation. Tesla is a great example of somebody that manufactures a car. It was designed for manufacturing. It was not an afterthought. So that's a great example of how we can actually go in and do this. One of the areas where we have a challenge is in electronics manufacturing. The average cell phone only has a lifetime of about 12 months. So it's very hard to build a manufacturing line that only survives one generation of electronics. So you need to be able to design a manufacturing line that can not only be used for the iPhone 7, but also for the 8 and the 10. And that poses a big challenge for how can we do this efficiently. We're seeing this, so we're starting to see factories that are fully automated, where we can actually do from one generation to the next by using sort of the right tools to be able to do this. So we build up a roadmap where the green is sort of how do you make money? And in almost all cases, it's about cost. How do you bring down the overall cost of doing manufacturing? And then it's about quality. How do you ensure that you have the right quality? And after that, it becomes also about how can we use this. The orange box is sort of where are the big gaps of building these systems. So it involves multi-robot collaboration. It involves how can you do much more easy systems integration. And it involves how can you collaborate with humans. These are still fairly big challenges for how we build good systems. And then the yellow box is sort of where are the R&D issues that we ought to be addressing to be able to make sure that we can deliver on these. The other thing that we're seeing in the manufacturing domain is that we're digitizing manufacturing. There's been a lot of talk about Industry 4.0 and the industrial internet and all of this. Today, it's primarily being driven actually out of Silicon Valley because we can do much better data analytics. We can build factories that are very, very lean. So a standard Kia factory in southern Georgia, the average storage time for material in that factory is 12 minutes. Stuff arrives, 12 minutes later, it's mounted in a car and it's on its way out. So they've sort of learned from Toyota's lean manufacturing and gotten it so lean that material is barely on the floor before it's mounted in a car. One of the things that's happening is that we're seeing this explosion in APIs that are being used to combine those. And if you sort of think about who owns those APIs, who is it that sort of is controlling this market? When I looked at this, I would say it's probably Siemens, GE, SAP, maybe Google, some of the big ones. I'm sorry, guys. It's Amazon. Amazon owns 40% of all those interfaces for the digital economy today. They're owning them primarily because they're releasing them in open source. So it costs nothing to get started. Later on, they're going to charge you AWS and all of these other things, so you're going to have to pay one way or another. But it costs nothing to get started. Biggest competitor to Amazon in the US? Walmart. Oh, they also have an interface all the way up at the top. But it costs if you want to use it. So for that reason, we're seeing a complete transformation about how we think about this. This is driving analytics. It's allowing us to do this and across many different areas. So it's not only sort of in manufacturing. It's all coming together. That's why we're seeing Alexa and we're seeing these various services come out, getting integrated into the factory place in such a way that we can use them to build very effective systems. So we're going to see a revolution, but it's, if I had to make a prediction 5 years ago, I would not have put Amazon at the top of that list as being the ones that are driving the future of manufacturing and the future of analytics. I would have put Google, SAP, Microsoft, and those companies. That's not the ones who are owning it today. Of course, we've seen tremendous progress on collaborative robots. 10 years ago, there were a couple of collaborative robots. It was Universal Robots, and it was KUKA. 10 years later, everybody has a collaborative robot. So we've seen them. They're still dumb robots, so the level of intelligence that we have in collaborative robots is relatively small. And in many cases, it's still a big challenge to be able to do systems integration. So building these and actually putting them on the factory floor, we would like to have a collaborative robot. And the vision is sort of, you come out and you present it to a mom and pop shop and you put in the robot and it does stuff. That's not the case today. The cost of doing systems integration is still 50%. As an example, most collaborative robots does not have a PLC built in. So we come out there and you put it up and say, okay, I still have to control the conveyor and all the other stuff in the store. So one of the challenges we have is that we're not close enough on doing this for collaborative systems. Of course, we're seeing lots of applications in sort of service, professional service applications, includes driverless cars, lots of professional applications. It's one of the biggest moving forward sectors where we're seeing real growth. So it could be anything from sort of concierge services to telepresence to even to the toys where we're seeing very significant, typically 30 to 40% annual growth. A lot of these companies have a significant US presence, which is very positive. Of course, we're going to see autonomous driving cars. God and everyone is promising that we will have autonomous driving cars on our roads soon. I'm a little bit skeptical. I don't think this. So normally my prediction is that 15 years from now, or kids born today will never drive a car, or never have to drive a car. So I'm skeptical when people say, in a few years we will all be driving around in autonomous driving cars. Yeah, good luck. I live on a campus where I have lots of these zombies walking around like this, and it's really hard to interface with those people because, So you're going to have to figure out how do you handle this in a reasonable way. It's encouraging that we're seeing it. At the height of the war in Iraq and Afghanistan, we had about 17,000 vehicles deployed in theater. Half of them were aerial vehicles. There's no reason today why we should have sort of pilots in the aircraft. It can be done perfectly well without. So the prediction is that 5 years from now, coast-to-coast and transoceanic air freight will be pilotless. I flew here last night from San Diego in a 737. The average time of pilot engagement in such a flight is 17 minutes. The remaining time he's playing Angry Birds or whatever he's doing. I want to take out the Angry Birds part of his job and instead have them sit and basically become air traffic controllers where they can manage a fleet of those. If I do this, I can build an aircraft that doesn't have to be pressurized to the same level. It doesn't have to have a restroom on board. It doesn't have to have a lot of plumbing that is in place today for it to be manned. And at the same time, as a pilot, you can go an 8-hour job, go home and take care of your family. You don't have to sit in a weird hotel room somewhere. The only thing we're missing is a legal framework to make this possible. We think Congress will approve this within 5 years. To be able to do this. It's going to take a little bit longer for passenger aircrafts. Most of you are not very comfortable flying in an aircraft where, row 1 is actually the front seat with a great view of the runway. So for that reason, it's going to take a little bit longer. We're going to have to build up some experience before we're ready to do this. But it will come relatively soon. All of the big companies are ready to deploy this very soon. Of course, we're seeing big applications in healthcare. In the surgery, we've already seen successes. We're seeing great progress also in the radiation suite. Most doctors actually care more about themselves than they care about you. So they're deeply worried about getting radiation exposure. They're in the OR 200 days a year. They don't want to get radiation exposure. So if we can use robots to take away the radiation, if we can take robots and use them to get them better ergonomics so that they're not hurt, this is a really big deal. So we're going to see a significant progress on seeing very different surgical robots than we've seen today. You'll hear later on in some of the panels about exoskeletons. Rich is going to talk about one of those. And we're going to see how we can use this to get people up, use this to go around. So we have a fair number of people that get spinal cord injury and other injuries. We can get them up and walk 4 to 6 hours a day. This helps with the vascular systems and all sorts of other things, and it gives them independent living, which is so important. I haven't found a good example of a service robot for the home that I like, so for that reason I have a sketch here until I find something that I can actually point to and say, I think this is credible. We're seeing a proliferation of companion robots. God and everyone is building companion robots. I would say they've all failed. And the way I measure it is time to boredom. How long does it take before I say, yeah, I know what it's going to do next? And time to boredom is typically measured in minutes, not even in hours. So for that reason, I think we have a big challenge of getting to products that are actually good enough that people are going to use them in the long term. It has to be flexible enough. We're starting to see good technologies like the Alexa and Google Go and these systems that we can build in. So far, they haven't really been leveraged to do this well enough. So we're going to see a big proliferation of these robots, but they have to get to a point where they're interesting enough that they can maintain our attention for a little bit more than 5 minutes. Of course, we're seeing big progress on first responder robots, whether it's firefighting in Northern California or deploying in theater for nuclear or those things. So one of the big use cases in the US is maintaining nuclear waste. We spend $8 billion a year maintaining our nuclear waste, not to improve it, just to make sure it doesn't get worse, costs $8 billion a year. So there's a huge opportunity to figure out how can we do this significantly better than we do today, because we really are very much challenged by the waste we have and how we do this well. One of these days we'll get a big earthquake here. So how do we make sure we're actually prepared for this? And we're gradually seeing this. Again, in most cases, the biggest challenge we have for these systems is the user interfaces. It sucks. There's no other good word for it. It's just like you look at it and you're like, really? You did not go to school for computer graphics or HRI before you designed these? They're terrible. So we need this. So we've seen major progress on driverless cars, on seeing this, but we're still missing some of the associated legal frameworks that allows us to use these in a reasonable way. If you design a autonomous driving car today, you have to figure out how do you break the law. We all break the law all the time when you drive, when you merge into traffic, when you do all of this. So how do you design a car that is sort of just enough entrepreneurial to make sure it can survive in real traffic and not being stuck at the first corner? So there's a number of these challenges of how do we do this well? How do we do this well? The same thing for the unmanned vehicles. We're seeing tremendous progress on deep learning. I'm not convinced deep learning is the answer to machine learning, but we've seen progress and we're seeing this move forward, which is very encouraging. And we're seeing collaborative robots as one of the fastest growing segments for going out there, both for manufacturing and for the home. And of course, we're seeing Internet of Things getting slowly integrated into this in a way where we can actually use it for some interesting things. Areas where we've not seen much progress, gripper technologies. Most of our grippers still are terrible. We haven't seen real progress on grippers in a very long time. The good news is that we're seeing a lot of progress on new material science and other things that is sort of pointing to a horizon where this might be possible. The same, we don't have effective interfaces. Most of these, if you buy an industrial robot today, you have to go for a 1-week course to learn to use it. And afterwards, the interface is still terrible in comparison to people go home and do all sorts of things with it. And the systems engineering for these systems is still terrible. So we look at some of the things where we think we need major progress. It's on flexible mechanisms. It's both to make it so that you can make it safe to use it in the presence of humans, so that you can use this to get to the right level. Much better collaborative systems. We need long-term mixed autonomy. Who can show me a robot that's been running for 8 months uninterrupted? Very few. Most research labs are very proud when it runs for 30 minutes. And the same, we see results coming out of computer vision where they say we had a 92% or even a 99% success rate. If you're from industry, you're going to say, okay, that implies your robot is broken 15 minutes every day. That's just not acceptable. So we need to figure out how we can do this much better than we could before. Of course, we're seeing cloud and data streaming. We are hoping we can get to a real digital tool chain where I can go out, I can install an application, I can press compile, and it will actually work. So here are all the collaborative robots. Everybody has a collaborative robot today. They're very good. They're great for being able to be used in human proximity. The problem is that most of them is just a robot. It's missing a PLC, it's missing a useful user interface. I want this to be so that, there is zero learning curve. I give this to a mom and pop shop and they can actually figure out how to use it. It has to almost be the IKEA model. You can drive home with a piece of furniture, and most American men can assemble it without having a lot of spare parts left over. How can we get this to a point where I can actually program this in a reasonable fashion? It's not there yet. So this is a good start. Great mechanisms, lousy software. You might not be aware of this. The average American plays one-person computer games 30 minutes a day. Some of you are picking up my slack. I don't play computer games at all. But other people do. The average 20-year-old American male has spent 12,000 hours playing computer games. That's 10% of their life. It's more than 10%. It's more than 10% of this, and more than 10,000 hours. That implies that if you give them an interface like this, it's in their spinal cord. They can use this. Why do we design user interfaces for the factory floor and for all sorts of other things that still are sort of a decade behind? We need to get into the 21st century and use this technology to design systems that are really effective for this. The other, we're seeing sort of a revolution in terms of sensing. And 96% of all robots delivered today do not have a sensor in the outer feedback loop. We need to get sensors into the outer feedback loop. The gray area up here are old-time 35-millimeter cameras. The blues are sort of point-and-shoot cameras that you would go and buy. But the really interesting one is sort of the orange here. This is cell phone cameras. We've sold more cell phone cameras the last 5 years than we've sold cameras in the rest of the human world. So, so there's a huge opportunity. If you go and ask a company like Qualcomm, what's the cost of a camera? A 1-megapixel camera is $1. The processing power to process it is $9. So for $10, you can get all of the hardware you need to be able to put a vision on your robot. So we're starting to see some robot providers that basically put a robot at every joint or a camera at every joint because it's cheap enough. It's $10. Even if you have 6 joints, it's $60. It's not a big deal. So we're going to see a major revolution on how we can do this and how well we can do it. We will see much better progress on doing much better perception for our systems. We will get to have semantic models. I'm still looking for the vision where I can take my robot home, like one of Eric's home robot, and basically be able to take it on a home tour and say, this is the living room, this is the kitchen, this is the bedroom, this is, and then it would actually be smart enough that it would understand when I say, could you bring me a beer? It will not start by looking in the bedroom. It will sort of be smart enough to figure out I probably need to start in the kitchen. Some of this there will be a big revolution on what do we do at the edge and what do we do in the cloud. How do we leverage cloud systems to bring down the economy of this? Still very little progress on non-visual modalities. You might not be aware of this. You all have 300 mechanoreceptors at your fingertips, at each of your fingertips, and we're incredibly good at this. We don't have this for robots yet. We need this. I have a video, I don't have time to show it, but if you take a person and you take away their haptic sense, we're very handicapped in terms of how we can actually manipulate objects. So we need to get this technology in there, and that's one of the things that we're working on to figure out how we do this well. An area which was mentioned before also by the chairman of NATO is that we need to think about education. Education is going to go through a revolution, but it's also very important that we don't think about education as, did you get a college degree? Most of these people that will get out there will get to a trade school that are on the floor, that a lot of places. So you can't make the assumption they have this. I used to live in Georgia until about a year ago. In the state of Georgia, 30% of a generation of young people never graduate high school. This is our future workforce. So you can barely make the assumption they can read. You can make the assumption they can play computer games. They can use a cell phone, but you can't necessarily make the assumption. So we need to figure out how do we build up sort of an educational strategy that makes it possible for all of these to be valuable contributors in the workforce, and at the same time we need to build robots that have zero learning curve. It's an interesting challenge of how do we do this and how do we build this in. So I'm very excited about the things that we're doing in collaboration with NATO about the World Robotics Summit, because we are going to look at some of these challenges, and it's a great chance for you to come and look at some of where's technology going and what are some of the opportunities. So to wrap up, we are seeing a very strong growth overall in robotics. If you look at it in comparison for the robotics market worldwide, we're seeing tremendous growth. The biggest growth is in China, not in the US. But still, we're seeing about 40% annual growth in the US. For the service robotics market, we are still, in many respects, the de facto leader on this. There are more than 20 million Roombas in operation today. And we're starting to see more and more of these that are being deployed out of here for this. We need fundamental research on making them truly collaborative. Most of them are sort of collaborative today is defined that they don't hurt people. I want a little bit better than they don't hurt people. We need much better perception than we have today. I'm not happy with 99% rate. I want 99.999. Then we're talking. We need interfaces that can be used by somebody that has used a computer game or less. We start to see collaboration between robots. What if I had a federation? I think I have 8 robots in my home. Today they don't collaborate. I want them to actually collaborate on doing things in my home. We need to be able to do much better systems engineering. As I mentioned before, 50% of the deployment cost is systems engineering. That's way too expensive. So we have good tools in other areas. We just haven't gotten it to the robotics domain yet. We need to really figure out how do we build these systems that are robust. So if we're building autonomous driving cars, 1 failure per year is not acceptable. On the average, I think Gil from Toyota said, you have to drive 100 million miles between accidents. That's what humans do. That's a tall order to figure out how can we do this, and how can we do this well. And then we need to make sure that we educate the next generation engineers and operators in such a way that we can do this really well. And then doing research where it doesn't get translated into somebody making money is in most cases a waste of time. So we need to figure out how we're better at doing this. And with that, I'll say thank you.